A2 over D. What's A1?
XL.
Good. So I have epsilon sub naught. A, so this is my equivalent capacitance. A1, sorry, you just said it. There were faster ways. XL over D plus, in the area of 2,
L times W minus X.
say it again.
L times W minus X.
Epsilon sub naught, W minus X times L. Now we're trying to solve, so what we measured here was X was measured and the equivalent capacitance was measured. Actually, he was doing overlapping area, so actually he was measuring that and that. That's what he was measuring. So X depends on that. I was trying to think of how would you actually get it to something you could plot. I think we'd have to plot versus X. Let's do it.
They didn't measure the amount they shifted.
They did measure the amount they shifted. What I asked them to plot was capacitance versus overlapping area. So that got messed up because the overlapping area was the whole thing, but the dielectric wasn't over the whole thing. Sorry, I cut you off.
No, you didn't.
I think if you're doing it this way, you would have to plot capacitance versus how far you shifted it.
Wouldn't the plates eventually just touch after the dielectric was moved past?
Well, presumably if they did, yeah, you would have to. I'm not quite sure how they managed to keep them not touching when the paper had shifted all the way off. I just found out this morning that's the way they did it. So I'm really curious to see how it comes out.
Wonder if it was one of those on the way to overload readings.
Yeah, and it's possible they saw a number and said, oh, let's write that down, and stopped it before they had a chance to hit overload. So it's quite possible their lab will be pure crap. So I have my equivalent capacitance is equal to E sub naught XL over D plus kappa epsilon sub naught WL over D minus kappa epsilon naught WX XL. Oh, that got messed up. Kappa epsilon naught XL. So what you're going to end up with is, if you're plotting versus X, we need the X's together. So this is epsilon naught L over D 1 minus kappa X plus kappa epsilon sub naught WL over D. Is that right? Did I make a careless error somewhere? So if you plot capacitance versus how much you shifted, the slope would be equal to epsilon naught L over D times 1 minus kappa. So D times the slope over epsilon naught L equals 1 minus kappa. So kappa equals 1 minus D slope over epsilon naught L. And the intercept equals kappa epsilon naught WL over D. That's just the area of the plate. So kappa would be the intercept times the distance between them over epsilon naught area. If you can resolve the issue of the fact that the places have to stay parallel at the same distance apart as opposed to sagging a little bit. Wow, that might make it into a lab next year. Really curious to see how it comes out. All right. Questions? All right, I'm pretty sure I know what you're thinking. We haven't done enough math, so let's do some math. Actually, can I see the notes from Monday or last Wednesday? The battery disconnected. Sort of a step backwards here. So I have some distance d between them. No dielectric in between, so kappa initially 1. Area of the plate A. D is much less than the square root of A, so we can use the infinite plate approximation. Hooked up to a battery. We start out with some initial voltage, delta V sub naught, across the capacitor. It has a certain charge on it. Configuration gives us certain capacitance. The electric field, magnitude of the electric field from the plates, we're going to call it E sub naught. And the total electric field is equal to E sub naught because there's no dielectric. And the electric field from the dielectric equals 0. All right, first thing I'm going to do is I'm going to separate the plates. So the distance between them, so I guess the distance initially is, we'll call it d sub 0. So that's our starting point. I now double the distance. What changes? Or what stays the same? I am going to simplify one bit of notation. I'm just going to call that E sub naught. Just so I don't have to write as much. Okay, so all I've done is move the plates apart from one another. What will stay the same? Yes. So this is still V sub naught. What do we know is gonna change? Or what are the formulas we're working with here? Try it that way. Give me some formulas that relate to any of these things.
Capacitance is charge over voltage.
All right? Give me another one. Are you gonna make Benjamin do all this? I guess so.
Voltage is negative E over D? Or like the electric field?
It's, the voltage is the negative electric field dot. Let's go with delta X. In this context, ignoring sign, and I think that's what you're going for, that equation.
Yeah.
Which E is this? We have E from the plates, E from the dielectric, and E total.
Ed.
Sorry?
Ed.
No, which, this E and Ed stands for which of these?
Oh.
Total.
Sorry?
Total.
Yeah, it is total. All right. We have at least two more equations. Three, depends on how you want to do it.
Capacitance is epsilon sub naught A over D.
Kappa, epsilon is not A over D. Did you say kappa? Yeah, when I did it before, there was no dielectric in it, so kappa was 1. This is true for a parallel plate capacitor.
Oh, yeah, this is from up here, like Wednesday, I think.
Okay?
E equals sigma over epsilon, which is also equal to the charge over the area, epsilon sub naught.
Sigma over epsilon,
Sub naught.
so not.
Yeah.
Which E is that?
The magnitude
Of,
the total. Of the plates.
yeah, that's the plates. If it's just epsilon sub naught on the bottom, it's plates. So it's Q over epsilon sub naught A. If we want total here, sigma over kappa, epsilon sub naught. Let's see, do we got another one? So we got plate. Oh, how do we find the electric field from the dielectric? Or the strength of the dielectric electric field?
There is no. There's no dielectric.
Well, okay, but the formula. If a dielectric happened to get thrown in,
What is the bottom of E total says?
the bottom here,
No, yeah, that, not the top. Does it say Q or A?
trying to figure out what that word is.
No, the under,
Like my finger
Below
goes
it.
left, right, up, down, down.
yeah,
All right, what is this?
yeah.
Oh, that's a sigma. That's the surface charge density. Or as some of you did in the flash quiz, the eta. I prefer sigma, but we use the textbook which uses eta. So that's Q over A kappa. That's all. All right, we'll come back to the dielectric. All right, so Since there's still no dielectric in it, it's not gonna impact us right now, so that's gonna stay 0. All right. Based on our series of equations here,
C is half, cut in half.
all right? So 1/2 C sub naught.
And then Q is cut in half as well.
We got 2 more.
Total electric field is double.
It doubles.
Oh wait, no, it's half. Because it's V over G.
Okay, so that's 1/2 E sub naught. And the electric field from the plates.
It's halved as well.
Yeah. If there's no dielectric, these two are the same thing. All right. So we've now doubled that. Now what I'm gonna do, put a dielectric in. Kappa is equal to 2. No, just so that there's differentiation 3. What's gonna stay the same?
How come V is the same if V is electric field times the distance? And if we double that distance,
The electric field got cut in half.
oh,
Because the charge on the plates got cut in half. So as you move the plates apart, there's less of a draw. The positive plate's not really pulling the electrons anymore, and so these electrons said, hey, we lost some, the positive charges have lost some control, let's kick some of these electrons out.
okay.
Voltage is still the same.
Say it again?
Voltage is still the same.
Why would it still be the same? You were right, it does stay the same, but why does the voltage stay the same?
The dielectric isn't getting rid of voltage, it's just.
Okay, but that doesn't really explain why it stays the same.
The Kirchhoff thing.
Yeah, the Kirchhoff thing. Whatever potential gain I have going across the battery, I have to lose it going across here. So, because it's still hooked to the battery, the voltage has to stay the same. As long as the battery's connected, voltage is not gonna change. All right, so my voltage is staying the same. My distance, I didn't change the distance. My area hasn't changed. What else is changing or staying the same?
Is the capacitance now 3/2?
And how'd you get that?
The distance was halved, but once kappa was added in, it, using our second capacitance.
That one, yeah. Just one tweak of the wording, the distance was doubled. The capacitance was halved from it. All right, so we now have 3/2 the original capacitance.
Should be 3/2 the charge.
Based upon the first formula. What's the total electric field? What's gonna happen to that?
So,
We get half again,
Why would it get halved again?
because it's related to the voltage and the distance, and neither of those have changed.
So it's not halved again, it's still one half.
One half again.
All right, the total is one half the initial, okay? What about from the plates?
It'll be 3/2 times the plates.
Because the charge is 3/2 the original, and everything else is the same. All right, now for the dielectric. What is the electric field because of the dielectric?
The difference between the plate and the total.
Yeah. Because if I've got a positive plate and a negative plate, my electric field from the plates is 3/2 E sub naught. The electric field causes the dielectric to polarize. So I get a bunch of polarized molecules here. Each one with its own tiny little electric field. And that electric field has to be so that my total is half of what I started with. So my electric field, now, these are strengths here, but the difference between those is this. And so the magnitude of the electric field from the dielectric is the strength total minus the strength from the plates. No, try that one again, plates minus total. But it is in the opposite direction of the electric field from the plates. All right. Let's disconnect the battery.